Hi, today we're going to talk about something that we're going to use in math and science. The middle school math and science teachers have agreed, all right, to use this um, set of steps in order to solve uh, formulas in science and word problems in math, and it's called IFSMU. So this is the introduction to IFSMU. Several years ago, Mrs. Angler came to me and said, Mr. Bossert, your math kids, they can't solve, they're having a hard time solving these science equations, all right? Um, for the formulas in science, and they're getting these things wrong. And I would look at what she was, asking the seventh graders to do, and they were really all basically 1 and 2 step solving easy equations. I said, there's no way my kids are getting these wrong. And she'd show me the test, and they were. And so we were trying to come up with a way to make it easier and have the kids be more successful. And so we looked around, we found this IFSMU, and it stands for some steps that we're going to take in order to solve and make sure that we do everything correctly, right? And make sure that everybody's successful. Okay, and so IFSMU, IFSMU, stands for these words. I stands for identify. Identify the variables or the parts in the problem. F is the formula. Choose the correct formula based on what variables are there. S is substitute. Once we pick the right formula, we're going to substitute our known values into the formula. And we're going to leave the ones that we don't know unknown as variables, and then we'll solve the equation for those to get the answer. Now you can tell the science teacher came up with this because the M part is math, do the math. Well, that just basically means solve the equation. All right, so we're going to solve the equation as best we can using our inverse operation steps, just like we would do in math. And then the U is to add the correct or choose the correct units to put onto the answer, right, from the identify step above. And so here's a formula that we use a lot in mathematics, okay? We can also use it in science. It's dealing with rate and distance and time, speed, distance, and time. Rate or rate of speed, t is time, and d is distance. So we have d equals r times t. We use a lot in math. We also use this one, this other rate formula. This is a for the amount of something, right? The d equals r times t, if you're driving 50 miles per hour for 2 hours, you would drive 50 times 2 or 100 miles in that time. This other one, a equals r times t, is dealing with the amount of something. Well, so if I get paid $8 per hour babysitting and I babysit for 4 hours, the amount of money that I would have would be 8 times 4 or $32. In science, they use S equals d over t. But that's really the same formula as this one up here. Distance equals rate times time. If you divide, but the rate they're talking about in science is a rate of speed, so they can use S. All right, so here's a sample question that we might use, right? We've got Sally ran 15 miles in 2.5 hours. What's her rate of speed during the run? So I look at the problem, and this 15 miles is part of the problem. That's a distance. So that would go in place right here. It's 15 miles is the distance. 2.5 hours, that's the time. And the question is, what was her rate of speed? So they are actually asking for the rate, so we'll call that x. And then they all have to match, so the label on rate of speed is going to be miles per hour. Or you could say mph. And so, whoa, mph, get over there. So if we could take all of those, that is identifying the variables or parts of the problem. So all that would go as my first step, the I step in IFSMU. The F is choose the right formula. Well, so it's this one right here, D equals R times T. All right. S is substitute in the known values. Well, oh, I missed this. Distance is 15 miles. That's all part of it. So we need the labels up there. Okay, so substitute in the known values. So I've got 15 miles equals R is X miles per hour times the time is 2.5 hours. So if I take a look at this equation, it looks kind of complicated, right? And this is where the math and science teachers decided that in science they had a hard time with these because they involved the labels here within their equation, MPH and HRS and mile. It looks like there's a lot more variables involved than there really is, but really there's only one unknown, and that's the rate, which is X, and X miles per hour. So what we decided to do is, and this is a very, very important piece, is that when you substitute, do not put the labels in your equation. Only list the values. All right. So let's see what this looks like when I get rid of the labels. So now it just looks like, what does it look like? I don't know. It looks like 15 equals X times 2.5. Or we would say 2.5X. So when we divide by 2. So all we really have here is, right, 15 equals 2.5x. Divide by 2.5 and we get 6. And then that's the M. That's this part here. That's solving the equation and doing the math. And for the U, the unit, right, we go back up in and we see that X was miles per hour. So that's the unit. So it's just 6 miles per hour, and that's the answer to the problem. It got a lot easier once we just wrote the equation without the units in there. It just became a one-step easy solve. When the units were written in there, it looked like a whole big mess of stuff. Okay? And in science, you're going to be doing a lot of different formulas that deal with physics. Now, I know a little bit about physics. But the great part about what we're going to do here is you don't have to know anything about physics, you know, some, in order to solve these equations. Because again, this formula is force equals mass times acceleration. All right, it's this in science for physics they use this. This is the formula for force. And I know a little bit about that, but I don't know. I mean, force, I don't exactly know what that means. Mass, I know, is weight. And acceleration is how fast an object is increasing in velocity, I think. So, but, you know, your science teacher is going to work on how dealing with that and the science principles behind it. Math-wise, you know, all we need to do is follow my IFSMU steps in order to do this. So I've got a problem here. A 20-kilogram rock is pushed with a force of 300 newtons. What's the acceleration on the rock? So I just need to identify the variables. So I've got force, mass, and acceleration. And in the problem, the force is 300 newtons. So I'm going to write 300. Now, the newton is the label for force. And they give this to, obviously, in honor of Fig Newton the cookie. No. Sir Isaac Newton, right, the father of physics, who, let's see, the guy who discovered gravity because the apple hit him on the head or whatever that stuff is. So it is really, capital N is what they use for Newton. And the reason they do that and they don't call it, because really a Newton is a kilogram meter per second squared. That really is the label on a Newton. But this looks, yeah. So instead of that, they just call it a capital N for, it's a Newton. It is a Newton. But you can use capital N in its place. The mass was 20 kilograms. And the acceleration, I don't know, right? So that's x. All right, that's x. The label on acceleration is meters per second squared. Again, maybe you don't have really a handle on what that means. You don't really need to, but it's not, the square doesn't have anything to do with the number or the value. The squared is just part of the label. Just like we measure area in feet squared. We don't square the number, all right? We've got, you know, a square that has side lengths of 5. The area of that is 5 times 5 or 25, but the label on it is square feet or square inches or whatever the unit is squared. The label is squared, not the value. So the formula we'll choose is the force formula, F equals m times a. S means to substitute. So I'm going to substitute in, all right, the 300. Again, if you wrote it in with the labels, holy cow, does that look awful? Doesn't it look terrible? All right? So let's get rid of it. Let's only substitute it in. All right, let's substitute in just the values only like we were asked. So instead of now, look at that equation. That looks pretty nice. 300 equals 20x. I know how to solve that. Divide by 20, and I'll get 15. 15 equals x. If I divide both sides by 20, and then the u, I go back up, and x was meters per second squared. So it's 15, and then the label is meters per second squared. The 15 doesn't get squared. That's just the label for acceleration. All right, how many newtons of force is used to move a 15 kilogram weight accelerating at 4 meters per second squared? So again, you don't need to know the science behind what's going on. When you get to that part in your science class, your teachers will kind of go through those concepts with you, but mathematically, can we do IFSMU and solve the equation? That's what we want to make sure that we can do here. So I'm you're going to pause this, and then you're going to see if you can follow the IFSMU steps, and then we'll reveal them in a second. So go ahead and pause the video. Restart it when you're done. Okay. So hopefully you've identified the F, M, and A. Force is x newtons, 15 kilograms, and 4 meters per second squared. And obviously I'm choosing this formula. When I substitute in the values, again, I only substitute in values, not the labels. So my equation looks like x equals 15 times 4. And wow, this is the easiest equation in history. I don't have to solve. I just have to do 15 times 4 is 60. And then last, for the u, I go back up, and x was, the label was newtons. So when I solve for x, I get 60, so it's 60 newtons. And that would be the answer to my problem. All right. So we're going to work on this in class, and we continue working on the IFSMU steps. We follow the steps. One step solves. Very nice and easy. All right. Thank you. Namaste.